Hello guys and welcome back to the Art of Software. This is the second video in the Design-Driven Development series. In the last video we covered the foundational concepts of design-driven development. We discussed about what is it product quality and how we can actually define it. We mentioned other methodologies with a formal design steps such as V-model, and we raised the challenges in balancing agile and design. If you haven't seen this video yet, I highly recommend you to check it out first to have a solid understanding of the background before we'll dive into the topics of this video. As part of the Design-Driven Development series, today we'll discuss about how to integrate design into agile frameworks. We'll talk about what do we even want to accomplish in a design session. Then I will share with you a design template to make the process as easy as possible. After a general overview, I will demonstrate how to use the design template following a practical example. And the last topic for today is Design Next Generation. We'll explore together what is the role of automation in design. By the end of this video, you will know how to integrate a design step into your own framework. This is the main target of this video. Why do we even need these design sessions? The primary targets are planning and communication. Please remember this. Following Martin Fowler's article, Is Design Dead? Also, I explained about it in the previous video. We raised two main issues that might happen following a design step. The first one is that when you are doing an upfront design, inevitably you might find some aspects in the design that are wrong, and you will only discover them on the implementation phase, on the coding step. And the second issue is unexpected change to the requirements. Now, these things happens dozens of times to me, and I'm sure also to you guys. This is the reality for most of the companies. So how can we even manage the design well? In accordance to the issues that I just raised, I will share with you a few advices to manage the design effectively. Back to the planning and communication. First of all, design helps you to think and explore about the feature before you start the implementation. We have to manage an effective communication. It means to put focus on main aspects and less focus on neglected ones. Comprehensiveness is the enemy of comprehensibility. Remember this term. Design documentation, including the diagrams, should not be comprehensive. The code is the best source of comprehensive information, as the code is the easiest thing to keep in sync with the code. It's a great definition. It practically means that you need to focus on the key components in your design, to highlight only the essential attributes and operations in each component, and to maintain a brief and focused sessions. Now treat the result design as a sketch, not as a final design. It's perfectly reasonable to draw diagrams that help you understand the design and then throw the diagrams away. Drawing them helped, and that is enough to make them worthwhile. They don't have to become permanent artifacts. To make the design process as easy as possible, let's examine together the design template, and afterwards we can implement the tips following a practical example. Personally, I'm using Confluence as my main document management system, and in accordance I've created here this custom template. In the next videos I will also show you how we can use the test template for our work. Okay, so let's use this template, let's see how it works. We need to fill here the page properties. We can connect this page to an issue, in this case to Jira, and after the review we'll fill these 2 points. When the review happened and about the participants. Okay, so what are the actual topics in this template? Of course we'll start with introduction. Afterwards, we have the potential solutions. We will select one of the solutions and raise the recent known issues, and then present the high-level design, the architecture overview, the diagram, and API specifications. To make this video precise, let's put aside the low-level design and deployment plan. They're not part of this target of the video. We can talk about them later. Okay, so introduction. This section outlines the primary goals and objectives of the new feature. So my suggestion for the people who lead the design, you can even add here the Jira ticket if the topic is already explained there. If you want to add something else, some additional information, this could be the right place. But in general, we will talk about it face to face in the meeting. Okay, next is the potential solutions. Now this is a critical section in my opinion. The main point that is related to planning. We want to explore the alternatives. I can't think about any features that there is only one solution. There are always alternatives, and I think that this is the beauty also in our field. So this is the right time to think about the potential solutions. There are always repeated issues with potential solutions. For example, do I want to create a new microservice for this feature? Or do I want to use this and that frameworks? We want to add the advantage, the disadvantage, and the most important point, the estimation. And in my opinion, this is a surprising point, because practically the estimation should happen in the sprint planning or in the sprint refinement, right? This is also why I suggest at least to start to fill this template while the sprint planning happens. We want to start from the potential solutions and to have the ability to raise the flags as soon as possible if it might influence the sprint. Okay, after raising the potential solutions, the next thing is the selected solution. If the selected solution is pretty trivial after raising the potential solutions, I just recommend to continue here, but if not, this might be the right time to stop and have the relevant discussion with the right people. With the team leader, the product owner, whatever. We need to make a selection. Okay, in the selected solution, we want to define the chosen approach, of course, to describe the solution you have decided to proceed with. And you need also to raise the risks and known issues. Now, I just want to remind you what Martin Fowler said in his Design Dead article. Designing with an eye to future changes. Knowing the decisions taken now will have to be changed in the future. We have to at least mention the potential challenges and concerns of this selection. Afterwards, we have the high-level design, finally. Starting with the architectural overview. So just to provide an overview of the architectural changes or additions, same as the introduction, not critical in my point of view. And afterwards, we have the diagram. To make the session effectively, we want to visually present the solution. It is very natural for people to see the actual result using a diagram. This is what can actually make the meeting effective, because this might be the first time that the design reviewer sees the whole picture. We can do here a static or a dynamic diagram. We'll talk about it in a moment. And the last point here is API specifications. Now, especially if we talk about a feature that is being implemented by more than one person, we want the precise details. This is the way that the developers can be seen between them. This is the actual contract. Now the developers can use their own mocks while doing also the component tests and try to break the dependencies. Well, a lot of times the best way to understand a new concept is by jumping straight to a practical example. So let's do it together. Alright, so let's take the next ticket for example. The mission is an API key generation for data fetching. As a user, I want to generate an API that allows me to securely fetch data from this service. Like, for example, to send a list repositories request to GitHub. It should be authenticated and authorized, at least if it's private. Okay, the API key should ensure secure access with proper authentication and authorization mechanism. Great, let's go over the acceptance criteria. Users can generate an API key from the user interface. API keys must be tied to the user's account and stored securely, of course. Each API key request must be authenticated and authorized by the system, and the system should return an error if the API key is invalid, expired, or missing. Great, we already have the subtasks. For the front-end side, we have a UI for API key generation, and we can see from here that Stefan is assigned to this mission. The next subtask is to implement API key generation logic, and Jack is the assignee for this task. And API key validation, same. Jack managed this subtask. And in general, you can see also here that the main assignee of the user story is Jack. In addition, we have here the story points, a Confluence link, and the checklist, right? This is the definition of done. We discussed about it. And we can see that already Jack started the high-level design review. Okay, so just to connect it to the full software development lifecycle, just as a reminder, we discussed about it in the second video that I published. So in this case, after the sprint planning, we pull this mission from the sprint backlog, right? And as I said, Jack is responsible for the whole user story, and also Stefan managed the front-end side. We have here two developers, and when we start the design and test definition, on the high-level design review, the developers, Stefan and Jack, will be here, the architect and the team leader. Okay, so together, let's go over the design. Okay, so this is the design document. As we can see, Jack linked here the issue, the Jira ticket. We have the review date and the participants, Jack account, Stefan and Ewan, or Evan, or whatever, let's call him field. So first step is the introduction, right? This feature allows users to generate an API key, blah, 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 blah. Cool, we have the description also in Jira ticket. Let's go over the potential solutions. The first potential solution that we can raise is using an external service, or we can also manage the API keys in-house, right? Let's get a taste of the advantages and disadvantages in these two approaches. So if we want to use an external service, first of all, it simplifies the management, right? Offloads authentication and authorization, complexity to a third party. This is not our responsibility. It might be feature rich, okay, if there are built-in features like rate limit, user management, and JWT authentication, cool. In addition, we have scalability and compliance, okay, this is the external service responsibility. And maybe the integration will be easy. Okay, what about the disadvantages? So the main one is recurring costs, ongoing fees that scale with user growth. Always when exploring an external service, there is also an external dependency. With this approach, we'll depend on the external service. and also limited customization. We're now coupled to this external service. Is there anything else here? No. And the estimation here is 3, let's say, story points. Okay, 3. What about building it in-house? In this case, we have full control, no external dependencies, fully customization, right? We can tailor the solution for our specific needs and no ongoing costs. Well, maybe only minimal cost for the server and maintenance. But what are the disadvantages? So first of all, high development effort, of course, and also the security responsibility will be on our side. Okay, so I think it's pretty clear, but the estimation here is 9 points. It means that it might be 3 times harder than using an external service. Now, please agree with me that there is no one clear solution here. It depends on the company needs. And this is why I suggest to raise the flag here, to have a meeting with the relevant people before continuing to select the solution and the high-level design. Okay, also there are dilemmas about the API key types. We can use a JWT, JSON Web Token for the API keys, or we can use some custom API tokens. Pros and cons for each approach. I assume that you understand the use case. Let's say that we had this meeting with the relevant people and we selected the approach. After comparing the options, managing API keys in-house, okay, instead of using an external service, with the JWT-based tokens, instead of custom API tokens, is the preferred approach. This provides stateless, scalable methods for issuing API keys with embedded claims, such as expiration and user roles, while maintaining control over security and customization. Okay, if we'll follow this solution, we have also, of course, risks and known issues. What about the security issues? What about rate limit? We didn't raise it, it's not part of the mission. Is it acceptable if we want to do it now? And revoke API key. Is there a need to revoke the API key? Because it's not trivial to revoke JSON Web Tokens, and maybe if it is mandatory, so we will select a different approach. Okay, after we raised the risks and known issues and we accepted them, so we can continue to the high-level design. The current system allows users to interact with API via standard authentication methods, blah, blah, blah. Change to the architecture. Introduce a new API key generation service to the backend, tied to the user accounts. Implement middleware to handle API key validation and adjust the existing API request pipeline to include this validation step before processing data fetch requests. Alright, let's go to the diagram. Now this is a static diagram. I created 2 types of diagrams here, one to generate the key and one to validate the key. To generate the key, I used a static diagram. Static diagram or structure diagram emphasizes the static structure of the system using objects, attributes, operations, and relationships. Practically, I want to see here the control flow, the dependencies between components. On the other hand, dynamic diagram or behavioral diagram emphasizes the dynamic behavior of the system. So we'll see an actual data flow. I will present you both of the options. And I do encourage you to explore different types of diagrams. For example, I prepared this site, UML Diagrams Overview. We can see here 2 types of diagrams, the structure and behavioral diagrams as we discussed. Under each one, we have a lot of use cases. Activity diagram, state machine diagram, direction diagram. This is under behavior diagram, and as you can see here under structural diagram, the more also classic diagram, the class diagram, the lowest level, and other types here. Again, I do encourage you to go over it. In this case, I'll be using a block diagram. It's very similar to package diagram in UML. Alright, let's go back. By the way, it is being called high-level design. What does it mean high-level? I like to separate it by components. The best definition for components that I found is from Uncle Bob's book, Clean Architecture. He says that components are the units of deployment. They are the smallest entities that can be deployed as part of the system. We can ask the question which classes belong in which components. This is an important decision, and it requires guidance from good software engineering principles, such as REP, the Reuse Release Equivalence Principle, or the CCP, the Common Closure Principle, and CRP, the Common Reuse Principle. If it doesn't make any sense right now, that's perfectly fine. In the next video, we'll dive deeper into how to separate the components and define the internal design in each one. Okay, so back to the block diagram. Let's see how generate key looks like. So in this control diagram, we can see the dependencies. So the customer uses the front end of the application through the browser. And the client is familiar with the server side, right? This is the way that it sends this request. Post API v1 API key. And as you can see, the diagram here is very specific. On the right side, we have the internal backend services. I don't want to present them in this specific diagram. This is not the target of this design. So I want to treat it as a black box. Now the thing that is important here is the auth service, authentication and authorization service. So I can see that the gateway is familiar with depends on the auth service. Practically it means that this request will be sent to the generate API key. This handler depends on the secret and is going to use it to generate the API key. And we can also see here that there is an open question about revoke API keys, and it's under the module or package API keys manager. And in general, API keys manager depends on the database. It's familiar with the API keys database. Okay, let's continue to the next diagram. Now I want to present you a dynamic diagram to validate the key. Now in this case I use something very similar in UML to information flow diagram. Let's just see how it looks like. Information flow diagram. No, thank you. Okay, and we can see here the actual data flow. It is defined as data flow diagram. So let's see how it looks like. So it starts from the customer. The customer sends the GET request. Actually, also here we should see the front end through the browser. Anyway, so the request is being sent from here to the server side, right? Same as we saw before, to the gateway. This is the first component. The gateway receives the request, and we can see here the actual data flow. Instead of sending this request directly to the relevant backend service, as I explained in the example, instead it will generate this GET API request, API v1, API key, validate, toward, again, the auth service to this module, API key validator. As the name suggests, it will validate the key because the actual key is attached as an authorization header from the actual request from the user side. Now it will also use the internal secret to validate the signature. Let's say that this is a symmetric signature, and with the same secret we can sign and validate the signature. And the auth service will send back a response. If it is valid, so the request will be sent to the relevant internal service. In this case, the gateway will route the request to the relevant destination. If the validation has been failed, the gateway will send back a 401 response, an unauthorized status. I hope the diagrams help to clarify the complexity of the feature. And this is exactly what I would expect to see during the design session. Okay, let's continue to the last step here, the API specifications. And again, it is important here to be as precise as possible because we have here two developers on the same feature. We have Jack and we have Stefan on the front-end side. So this is their contract. We have the post definition to generate a new API key, and we have the get definition. This is just one example, and the API key is attached in the authorization header. And we finally finished the design session. So far, we have covered some crucial aspects of the design process. We talked about what we aim to accomplish during the design session, we went over the design template as a general overview, and we walked through a practical example to demonstrate how to use effectively the design template. But do you really think I wrote the entire design document by myself? Think again. In the next session, we'll explore the next generation of design, how automation can play a role in design process, including the potential use of AI and other smart tools to speed up the software development lifecycle. Stay tuned, and as always, please like, subscribe, and share your thoughts and feedback in the comments. See you in the next video.